Hi, this is Coach Dorf. We're going to look at a homework problem from section 4.8. Here we're given the equation 2x to the fifth minus x squared plus 1 equals 0. Part A, we're supposed to explain how we know that equation has a solution in the interval from -1 to 0. And then part B, we use Newton's method to approximate that solution correct to 6 decimal places. So the first thing I would do is let f of x equal the left-hand side of that equation. So the 2x squared, 2x to the fifth minus x squared plus 1. And then in part A, we're going to use the intermediate value theorem. Now remember, the intermediate value theorem says that if I have a function and an interval from negative, in this case, -1 to 0, and if the function is continuous and the function at -1 is less than 0 and the function evaluated at 0 is greater than 0, then somewhere it has to cross the x-axis. And in particular, in this one, we will see that in this case, f of -1 is below the x-axis and f at 0 is above the x-axis. And since it's a continuous function, it has to cross the x-axis somewhere. And if it crosses the x-axis, that means that the function has to equal 0. All right, here are the details. So we notice that f of -1, if I put that in, I've got 2 times -1 to the fifth minus -1 squared plus 1. So -1 to the fifth is -1. So this is going to be 2 times -1, which would be -2. Then I have a -1 squared, which would be a positive 1, but then has a negative out front, so that'll be -1, and then plus 1, and that all equals -2, which is 0, or less than 0. Now if I look at f of 0, well, that one's pretty easy to do because I get 0 minus 0 plus 1, which is 1, which is greater than 0. So by the intermediate value theorem, there is a solution to f of x equals 0 on the interval from -1 to 0. So that's part A. Part B here, we're going to use Newton's method to solve this, to get the approximation to 6 decimal places. First thing I have to do is I have to find, well, let me say this. First, Newton's method, just as a reminder, if I start with some initial point here, then the next point, x sub 2, is going to equal the initial point, x sub 1, minus f of x sub 1 over the derivative, evaluated x sub 1. All right, so the first thing I have to do is choose on x sub 1. Well, where am I going to choose for x sub 1? Well, I could pick logical points to pick since we're doing the interval from -1 to 0 is either pick -1 or 0. Let's see if we pick 0, what happens? So if I choose x sub 1 equals 0, then we want to plug these into the formula for Newton's method. So I'm going to have to look at f of x sub 1, which would be f of 0 in this case. And we did that earlier, and we showed that that was equal to 1. All right, now I need to look at the derivative of the function at 0. So first of all, let's compute the derivative. So remembering that my original function was here, my original function is 2x to the fifth minus x squared plus 1. Its derivative is going to be then 10x to the fourth minus 2x. And then the derivative at 0, if I plug that in there, I'm going to get 0. Now, what does that mean? Well, in terms of a graph, I'm going to have something like this. This is y equals f of x. At 0, I have a horizontal tangent line. And the derivative at 0 equals 0. Because of the way Newton's methods work, we want to find out where that tangent line is going to cross the x-axis. Well, if it's horizontal, it's not going to cross it. So we can't use it in Newton's method. And that also makes sense analytically, because if I try to solve for x2 here using the formula for Newton's method, what happens? Well, here I'm going to get 0 since we had f prime of 0 equals 0. And that's not good. So we can't use x of 1 equals 0 in this case. It doesn't work with Newton's method. All right. So we're going to instead now, we're going to try choose x of 1 equal to -1. When we do that, again, we need to figure out what f of -1 is, which we did earlier, and we saw that that was -2. Then we're going to have to look at the derivative at -1. And remember, that's going to be 10x to the fourth. So I'm going to put -1 in there for x. minus 2x. And so I'm going to put negative 1 in there. When I do that, I get 10 plus 2, I get 12. All right, so then we can figure out the second point in our iteration. And we started with x1 equal negative 1. Our second point is going to be x2, and that's again going to equal x1 minus f of x1 over the derivative of f at x1, which is then going to be negative 1 minus negative 2 over 12. And that's the same thing as negative 1 plus a sixth, which is negative 5/6, which is approximately equal to negative 0.833333. We're going to do 6 places past the decimal because that's what they want us to do. We want to be accurate to that. So we're doing 6 places past the decimal point here. All right, so that gives my value for x2. Now I'm just going to keep a tally off here to the side that we can keep coming back to. We started with x1 equals negative 1. And now for x2, we have negative 0.833333. All right, now we're going to figure out what x3 is. x3 is going to equal x2 minus f of x2 over the derivative evaluated at x2. So we need to figure out what f of x2 is and what f prime of x2. So f of x2, which is going to equal f evaluated at negative 0.833333. All right, and that's going to equal 2 negative 0.833123 again to the fifth minus negative 0.833333 squared plus 1. All right, which is approximately equal to 0.498197. To figure that out, I used a calculator and I rounded it up so it had 6 places past the decimal. All right, now I need to find the derivative at x2, which would be the derivative at negative 0.08, which is going to be then 10 times negative 0.833333 to the fourth minus 2 times negative 0.833333, which is approximately negative 6.489189. Again, I just plugged the numbers into the calculator. I used Desmos to do it, and that gave me the answer. And so then x sub 3 is going to be equal to, again, it's x sub 2 minus f of x sub 2 over the derivative at x sub 2. So if I plug those numbers in here, x sub 2 was negative 0.833333 minus, and then f sub 2 we had up here, which is going to be negative 0.498197 over, and then down here I've got this number as negative 6.489189. And just so it's clear, this has a negative there in front of it. All right, and when I approximate that answer, I get negative 0.756560. So we'll put that back up here. This was negative 0.756560. All right, so we've got 3 values here. We see that the difference between the second and the third, they don't match up on all 6 of these digits past the decimal place, so I have to keep going. So now we're going to do x sub 4. So what's x sub 4 going to be? X sub 4 is going to be x sub 3 minus f of x sub 3 over the derivative evaluated at x sub 3. All right, we already know what x sub 3 is. Remember, x sub 3 is going to be negative 0.756560. So I now need to figure out what f of x sub 3 is, which would be f of negative 0.756560. And when I plug that into my formula, I get approximately negative 0.068115. Also, I do the same thing with the derivative. So that's going to be the derivative evaluated at negative 0.756560. Putting it into a calculator and rounding it to 6 places past the decimal, I get 4.789343. So then x4 is going to equal, using this formula here, it's going to equal negative 0.756560 minus negative 0.68115 over 4.789343, which again, I can, using the calculator, I get negative 0.742338. So let me put that back up here. X of 4 was negative 0.742338. I have one place past the decimal that connects. That's the first place, but not all 6. So I have to keep going again. So now we're going to have to figure out what x sub 5 is. And it's the same process again. X sub 5 is going to equal x sub 4 minus f of x sub 4 over f prime of x sub 4. And again, we're going to use x sub to be negative 0.742338. And so then I need to figure out what f x sub 4 is, which is going to be f of negative 0.742338, which, using a calculator, I got that to be negative 0.001922, which is really nice. The closer that gets to 0, that means my value for my x sub n is going to be not much different than the previous one. And then I look at the derivative, f prime at x sub 4, so that's f prime at negative 0.742338. And when I do that, I get 4.521410. So x sub 5 is going to be equal to negative 0.742338 coming from there minus negative 0.001922 coming from here over 4.521410 coming from here. And simplifying that with a calculator, I get negative 0.741913. So I'm going to now put this back up here in my chart. So I have negative 0.741913. Notice now I have 2 places past the decimal that match. They both have a 7 and they both have a 4. So we're getting closer, but not close enough. So now we'll do x sub 6. Again, same process here, where I'm going to use x sub 5 to be negative 0.741913. Then I need to figure out f of x sub 5, which is f of negative 0.741913, which turns out to be approximately equal to negative 0.000002. Really good. Again, it's getting very, very close to 0 for our purposes here. And then f prime at x sub 5 is going to be putting this in here, putting it into a calculator. I get that to be 4.513612. And x sub 6 then is going to be negative 0.741913 coming from here minus negative 0.000002 coming from here over 4.513612 that comes from here. And when I plug that into the calculator, I get negative 0.741913. We're rounding it to the right number of places. And that's exactly what I had for x. So x sub 5 and x sub 6 match 6 places past the decimal place point. So the solution in the interval from negative 1 to 0 is approximately equal to negative 0.741913, correct to 6 decimal places. And we're done. Thanks.